Greetings class, I am Felix Lawrence, and today I'm going to be presenting on how the mandates for the FAA radio altimeter interference tolerance, how it relates to 5G spectrum spillover. So the main question at hand is whether the signals from nearby 5G tower, whether it interferes with the operation of radio altimeters in the main phase of flight, or the most critical phases of flight, and if so, what action should be taken. So during this presentation, I'm going to be giving the background information, key terminologies, and I'm going to be giving like the different views on each side. I'll be speaking on the controlling laws, court cases, the current status of like where the issue is as of this moment in 2026, and my proposed solution to the issue. Well, the solution that I agree with. And I'll also include my biblical worldview as it relates to the decision making. So the main issue, as I said, is whether the 5G signal is able to like interfere with the performance of a radio altimeter, and is during the main phases of flight, during takeoff, approach, landing, and so a radio altimeter, that is the instrument that is used in aircrafts, and it is used to measure the true height above the surface, so AGL, above ground level, and it is mainly used at a low altitude. So that is when it is most important, because it is used for warnings such as TAWS, Tow Awareness Warning System, and it is also used for automated systems like Autoland, and it highly influences the pilot's decision making during landing. So the cue that pilots hear, 100, 50, 40, 30, those callouts, those are the cues that pilots use to aid when they should flare. And so if the readings are faulty, especially if they are at a low altitude above the runway, seconds away from landing, it could lead to a catastrophic event. Also, it is also a regulatory and policy problem as well. So because there are two governing bodies, there are two regulatory bodies that influence like the decision that has to be made. So you have the FAA, the Federal Aviation Administration, and you have the FCC, the Federal Communication Commission. And so both of these bodies, they kind of overlap. They overlap because the FAA is responsible for establishing, or they have authority over safety standards in the aviation industry, and the FCC, they have regulatory authority over the use of electromagnetic spectrum for wireless communication. They also allocate the spectrums. Okay, so I'm going to be speaking on the difference between the radio altimeter and a barometric altimeter that we are used to in the Cessna 172. So the radio altimeter, it uses the measure it gives is the height above ground, like I said before, but it is different than the barometric altitude, which gives you your altitude in relation to mean sea level, MSL, and that is mainly used during en route phases of flight, and also it is used for separation of traffic at in class alpha. So the main technical problem, that is adjacent band interference. And even though interfering wireless signals is not like within the radio altimeter band, it may be outside of that, there could still be issues. It could still cause a problem if it's near the edge of the band, or if the signal is strong enough to interfere with the desired signal. So here are the key frequencies. It's 5G C band, It ranges from 3.7 gigahertz to 3.98 gigahertz. You have upper C band, which ranges from 3.98 gigahertz to 4.2 gigahertz, and radio altimeter band, which ranges from 4.2 gigahertz to 4.4 gigahertz. And there are two terminologies or two terms that is used to describe the potential for the interference that can occur. So we have blocking and front-end overload. Blocking occurs when there is a very strong, like, nearby signal that could decrease. That is where the blocking comes in. It could decrease or completely eliminate the ability of the receiving equipment to receive the desired signal. And also front-end overload. So front-end overload that occurs when the receiving component is subject to excessive energy and it can no longer function in a normal manner. And so both of these events can lead to unstable and missing, it could like lead to missing AGL outputs at low altitudes. An important thing to note is that every radio altimeter don't react in the same way. The risk varies based on the design of the receiver, and also how it was installed, the power level of the transmitting device, and also how far the transmitting device is away from the receiver. And because of all of those differences, like, that is why, like, this solution isn't as straightforward. Like, it's not like a one size fits all solution. So every aircraft cannot be treated equally, so there needs to be a tier, like a risk-based tier approach, or like a layered approach, like which I'll speak more of later on. And so about the background, so the fundamental laws, there's just three legal basis to this argument. So first you have 49 USC section 44701, and that grants the FAA the authority to determine the minimum standard for aircraft equipment and performance. And second is the requirement that the FAA has to send out airworthiness directives, or they have to take airworthiness actions if an aircraft or the component in the aircraft is not meeting the required standard. And third is NPRM. So NPRM, that is the Notice of Proposed Rulemaking. That is basically the mechanism used to initiate a rulemaking proposal. And the FAA, they use the NPRM. When they issue a proposed rule, they also accept public comments regarding the proposed rule, and then later on they may eventually issue the final rule. And so some different views on the topic. We have four of them. So, but the four primary positions in the argument. So first is the safety view. That is the FAA, and they believe that the long-term solution will require the use of better equipment rather than just like some temporary fixes, such as like the airport by airport temporary solutions they have, which is NOTAMs. That is just a short-term fix and not long-term. And the FAA, they also believe that there should be like a minimum interference tolerance in every aircraft, so it should be able to withstand a certain amount of tolerance, and that number should be known. And the second position is the FCC, the wireless industry. They believe that the emission limits for the wireless communications are sufficient. And they also think that the mandates that the FAA want to propose, it is due to a overreaction based on like a worst case modeling basis, and they also think that would actually slow down innovation. Third is operators and manufacturers. They are represented by the airlines, for America and Lockheed Martin, and they basically want a uniform national approach. So they don't want no kind of individual airport by airport restriction. but they also want realistic time frames when it comes to compliance, and also they want to make sure that they have like sufficient that there is sufficient components and parts available to them to make all the changes, and they want to have a clear understanding of what is required in order to obtain approval for the design and implementations. And the fourth position is the governance advocates, and they pretty much focus on how the system of the decision making is organized, right? So like who have authority, how the agency coordinates, and how rules are made. And they pretty much emphasize the need for the FAA and the FCC to coordinate their efforts together to resolve the issue. And they also want that the FAA and the FCC, they may clash again if there is any, when there are future spectrum allocations. So if the FAA were to adopt a final interference tolerance rule, I think most likely it would be a legal challenge using the administrative law as well as the State Farm Proceedings of 1983. And the concept basically says the federal regulatory agencies are required to review all the evidence in the record and to identify the primary issues involved, and then to provide a clear explanation of how it's chosen, and that the rule is reasonable based on the evidence that they have. And also the agency must be able to demonstrate a logical relationship between the evidence presented and the proposed rule. So there are also two additional legal issues that will influence how the courts consider the FAA final rule: the major questions of doctrine and how the courts construe the statute post Chevron. So major questions doctrine, that is West Virginia versus EPA of 2022, and that's where an agency adopts a regulation, and the potential it have to change the economy or the political landscape. And the agency they also must be given congressional authority prior to adopting those regulations. And the FAA they would most likely just like perform like the mandatory. The FAA they would say that the argument they would use is that they are just performing their mandatory duties as an aviation safety regulator. Like that's what they would say, like in defense to that doctrine, because a large scale retrofit mandate is likely to be a significant economic burden on multiple industries, like the airline industry and the traveling industry will significantly slow down. So I think that's what they would say in response to that. And the law provides 2024. Right now Chevron deference is no longer applicable, but it did provide guidance on how judges should like interpret the statute. So right now they cannot just like go along and argue with one side. So the FAA they will need to clearly show that the statutory authority is supporting the rule. And so as of today, the FAA interference tolerance requirement is currently being proposed in a NPRM, and it is not yet a final rule, but the airworthiness actions, like it is still relevant because it just shows that the FAA is still relying on like short-term solutions, short-term tools rather than like long-term tools, or actually having like a long-term solution. And also the FCC, the upper C-band inquiry demonstrates that there is an ongoing activity with regard to spectrum policy in the vicinity of 4.2 gigahertz, which is extremely close to the band of radar altimeters. So in my opinion, I think that the FAA, I do agree with the FAA. But I think the FAA, they should develop a minimum level of interference tolerance, and they should implement it in phases. So they should like implement it using risk levels for each operation, and they should also work closely with the FCC and make sure they have constant communication going on. And I think that because first of all, it would protect the operations at the greatest risk of interference first, and secondly, it will follow the data that shows the risk of interference is not the same for each aircraft or each situation. So it would actually follow that data, which is true. And thirdly, it will be more easily defended by the State Farm, since it will show the FAA had alternatives and that they were making their responses specific to the type of operations. And so my recommended solutions, my step-by-step implementations is step 1, they should set a clear performance floor and define what counts as an acceptable interference tolerance. And step 2, they should apply by risk. So they should work first on like low visibility and high automated operations, because those are the most critical, the most important, the most high risk operations. And they should allow multiple technical paths. So they could use like filters, redesign, or other approved fixes, whichever other fixes they can find or use. And last but not least, they should cooperate with the FCC, because if the FAA can cooperate with the FCC and they can share data, and they can actually come up with a better plan for the future, it would lead to increased safety. It will be a better legal fit, and there will be less unnecessary disruptions. And the practical advice for operators and manufacturers, I think operators, they should develop a list of radio altimeters, and they should determine like what operations or systems rely on each AGL data, and they should develop a multi-phased plan for upgrading those aircrafts and the airports, which are the most susceptible to having the issue. And they should also document decisions and compliance with audit requirements and legal review. And for manufacturers, I think they should certify and test any upgrades. And they should also verify that no warnings or automation issue results from an upgrade. And they should also make sure they maintain full certification documents for each upgrade. And now, so the practical advice for wireless planners and policymakers. I think wireless planners, they should I would instruct them to consider an airport area deployment. Well, they should label it as high sensitivity or treat it as similar to radar sites. And there should also be a requirement that planners verify their design and comply with the FCC emission regulations, and provide measurements data near approach paths for conflict resolution, so they can resolve any conflicts in advance of any potential operational restrictions. And to the legislators, I think they should be provided with clear rules on coordination between the FAA and the FCC, and consider transition tools if spectrum changes, interference risk to safety equipment. And so my biblical worldview, stewardship first, fairness second, and truthfulness third. The Bible says that we need to take seriously or act before danger occurs. That is in Proverbs. It says that in Proverbs 27 verse 12. And so if there is like a safety issue in technology, I think that it is wise. Well, the Bible says it is wise to actually act before danger comes. And so for fairness, we ought to treat everybody equally. When looking into the issue of fairness, it means that safety and the band goals, it should be pursued using evidence and not just trying to like not using false evidence or just creating anything out of nowhere. But like it should actually be fair, and they should be both parties should be thinking of one another while coming up with this solution. Truthfulness. We are taught to be truthful on our walk. We are taught in the Bible to walk in integrity. And so, even with the data, all the data should not be assumptions. It should be based on truthful data and research. And in conclusion, what are my key takeaways? And first, there are safety risks associated with using radio altimeter systems. But the overall level of risk, it depends on the type of system that is installed and which operational environment it's being used in. And second, the main statutes that can be relied upon as the legal anchors in determining the liability for damage caused by a radio altimeter system malfunction is section 44701, and also I used State Farm of 1983, and Loper Bright and West Virginia versus EPA. And these are my references. Thank you.